just a little warm up.
Yep.
We are live now. This is pretty cool. I hope everything works out successfully. Yeah, today I got Juan from Sapere, and we have some cool stuff that. Thanks for joining. Let me just see if everything looks okay. My son played around with my YouTube this morning, so I'm not really sure if I'm able to see or if I'm just gonna see some model trains. So yeah, tell us a little about yourself.
Sure. Yes. My name Juan Duque. I am resident in Denmark, where we have a little company with my colleagues Jonas Butcher and Torsten Lube. Our company basically does specialized integration. We navigate ourselves in the regulated industries, pharmaceutical and chemical industries, but we work around also in enterprise. And we have been in this game for between us three for more than 30 years. Me, myself, I have more than 18 years doing integration. So I started in the old business connector days, the good old business connector.
With business connector?
Oh yeah. We did a lot of stuff with business connector back then. My first real enterprise system was running on a business connector that we had it in a server under my desk for some time before we moved to a server room. But that was my start with SAP. And the last 2.5 years, 3 years, we've been working a lot with the SAP Cloud Platform. So not only cloud integration, but API management and mobile services. The whole technology side of SAP Cloud Platform is what we're trying right now to aim our consultancy side. And that's basically what we are gonna try to base our experience or our little story about how we managed to solve some problems on performance that we saw.
Yeah, let's I guess go back to the beginning. So I got some email from you in December where it said, hey, we had previously some performance issues and we solved it, and you shared some insights about what this performance issue was, how you got it solved. And I thought this was an interesting thing to share, because there is definitely a lot of learnings about this performance. And I think this is not, well, this is about going from 10 records to 10,000 or 20, 100,000, where you start to get some challenges. And these are the considerations that we want to cover.
Yes.
Based on yeah. There's some things that we will be covering and sharing in. And these came, at least the loop versus collections really came as a surprise for me. String building, I guess we'll cover that one. And then also how to monitor CPI utilization. And if you have questions, comments along the way, just put them into the chat. Then we can try to answer those as good as possible. Yeah, we got that. So this is the scenario. Tell me what's
Let's
this about.
Start a little bit about. So the diagram is a very high-level diagram, but I will say that it's one of the most classic scenarios that we all have seen in our workplaces, right? So we have a SAP system on the back, and the whole objective of this is to make a new application to display large amount of correlated data from different systems on a SAP Cloud Platform set of Fiori built UIs and applications and data visualizations itself. So where we started, we were basically requesting a lot of data from SAP. We had an OData service where we are pulling data. Depending on how much data it was coming and the type and characteristics of the data, we might need to make some expands on some more aggregations from SAP. Then we go into a data enrichment layer when we're requesting data from a lot of different systems and aggregating the data and making both judgments and calculations upon that data. We transform everything. We're working on everything in JSON at this stage. So even from the SAP side, we decided to start working with JSON out of the I think the lower footprint that we see in a JSON message rather than XML. And then it comes the more interesting part, that when we needed to store this data to be available for the front ends, we were storing it in a HANA Cloud system, where we use CAP to develop some OData services to allow us to store the data and to manage data and to consume it from the UIs afterwards itself. The interesting part, I think, that is we need to remember that CAP and is a framework to build microservices. So you're intended to work with a smaller sets of data and do with classic Web 3.0 fractions like pagination and consider your resources, not too much data. While in the SAP side, we're used to do like, give me all the data, I maneuver everything and then push all the data back in, right? So there was definitely some groupings and some transaction integrity that we needed to consider on this. Was very complex and a lot of logic that we needed to build. So we distributed the flow and in different processes depending on things where we are. So this orchestration is a total of a little bit over 19 integration flows that were worked together. And since it's an agile project that we're working on, all the different portions of it were built by different developers and then meeting in between. So it became a very interesting scenario, right? A very interesting scenario, how to build all of these large, complex, and try to make it work. So it was exciting, right? And then we came to the go live day. So we go to the next slide. Now, since it's agile and since it's safe, you had a question?
There was just one question I guess we can take along the way. What's a collection in CPI?
Sure. So when we mention collections, Groovy and JScript, they have an object within their standard data object modeling, which is called a collection. What collections are used is for iterating across arrays or data arrays or object sets itself.
Mm-hmm.
And there's a lot of
concepts. Yeah.
Yes. Yeah. And there's a lot of beautiful, I would call it beautiful functions and methods that have been built in when you're working with collections, right?
Right. Yeah.
Yeah. Yeah. Yeah. So we'll take a look in a second to see if it's a little bit more descriptive afterwards. No, but what happened to us, like, luckily this is as I said, it's an DevOps project. So we have been building minimum viable products on a step. But then we had now the big shebang, right? We were going to push all the data that we've been working for some months into it. And what happened is that we did a lot of testing. We knew that it was a process that was going to push a little bit on the usability of resources. So we actually had SAP come and give a code review, a design review, a go live readiness check, and all of that went very well. What I'm trying to get is that there was nothing in the design of it that was a fault of a developer or a misconception on architecture. Like, everything seemed very linear and very structured in what we have built. We have done a lot of load tests. We were not able to get the full data set from production. That's always a little bit complicated. But we did load tests with up to 80% of the full set of data, right? And it's a process that was taken in our testing 10 and 3 hours to process, right? So we were forecasting that in production, it will take 4 to 5 hours maximum, right? And that was our expectation, and our go live planning and window was all around that. So what happened is that we started running the process, and then the process already was on the 6th hour, and we still have not seen too much data in the target system. We didn't see for a very long period any activity, so there was no transactions coming out of SAP, no transactions coming into the target database. So it looked like nothing was happening in between, right?
And I guess this is the flow you have over here, where you are doing all the data manipulation, and then it's only towards the end you start posting data into the target.
And exactly in that point, we can see that a lot of our processes are in processing stage, but we couldn't really see any activity or pinpoint where is this really blocked, right? It has something begun to fail. We freaked out a little bit, I will say, and start to see what can we do. Can we cancel the flow? Can we? Do we have to wait? How long can we wait? We were people waiting on us to finish this, and then we noticed that other transactions in the tenant started to slow down. So we knew that something was bad at that point, right? So we contacted SAP, and to my satisfaction, SAP reacted very fast. If you go to the next slide, Daniel. So they help us finding out that there were very high CPU utilization at that point, right? There were very high peaks, so the tenant was overloaded. They couldn't really tell us where or why, like which flow was it or where in the flow was a problem. But they said like it looks like there's something wrong, right? And right now there's threads locked there. Yeah.
Yeah.
So they accepted that they needed to add an extra node to the tenant. So that's great that they were able to scale, and that was relatively fast. It's the first time that I see the actual escalation of a CPI tenant, which went fast and started working. Actually, we see immediately an improvement in how we were feeling the node, that transactions that keep on flowing. However, we still were not really sure how our flow was going to run, right?
Yeah.
When we got back to a stable system, we were able to run the flow again. We had to reduce the amount of data. We didn't want it to be in the same risk again. So we talked to the business to reduce how much data do we really need for go live and rescope our targets. And we were able to run the flow, but it still was 6 hours. So we were running like 40% of the data and still more time than we were expecting to do. So yeah, nobody was satisfied with that result, right? So and we knew that the business will start to go live a week after. So we needed to this needs to be solved in the coming days. So that's when we all get to our thinking
Yeah.
things and we start looking into the whole design of all the flows. One of the things that was bothering me a little bit, and you can go to the
I
next
guess
slide.
it's always fun to do that after you've gone live, and
Of course,
yeah.
it's super exciting, and of course, it was a super fun weekend for everybody. Yeah, so we started looking at the whole design, and one of the things that was bothering me was how we were grouping data. If you can go to the next slide. So let's imagine that we had 10,000 records. To post them into the OData service, we couldn't post all of them at the same time. So we needed to post them in small groups of maybe 100, 200 records for the microservice that is running on the other side, just to keep both the stability and performance, so we can actually scale on the other side on the right way. And to do that, we use a very linear approach, right? So the developer who built this, they say, okay, I have a JSON, I'm going to convert the JSON into XML, and then I'm going to put an iterating splitter and let the splitter do both the splitting and the grouping. So if you think about that, it's JSON to XML, then the XML, it makes blocks of 100, 100, and 100, and starts processing and posting each of those blocks. Something that it's very that is not written here, but something that we also realize is that when you do this kind of conversions between JSON and XML, you have to be careful about special characters, right? So many times people encode, and we did find them in base64 encoding before and after, right? So if you are base64 encoding 10,000 records, that's going to be painful, right? So then the question is, how do we avoid all these things? So the first thing that we did is move the grouping into code. So once we move into code, we were able to do some more effective and more performance-driven grouping of the records, which didn't need any much analysis, rather than give me these 10,000 records in groups of 100, right? We didn't have to do any transformations between JSON and XML. And the data that we needed to encode in base64 was reduced, because instead of encoding 10,000 times, we were encoding only, let's say, 1,000 times or 100 times, depending on the grouping that we have decided. We then we let the splitter do only the splitting action, which is, yes, give me the data, and I will split it into different processes to post them, but the splitter didn't have to do any additional work for it. And that was a very, very significant improvement on the memory utilization of the node itself.
Mm-hmm.
It also allows us to test things like parallel processing. Uh, After the go live, we decided not to go with parallel processing because we were pushing too much the target system. But it really shows us a way to actually be able to really, if you want performance, it teaches how to really, really drive for performance on different parameters on how you're using the splitters. So to do this, we made a grouping in Groovy code, and we made grouping based on just text files, and the grouping separator was a line break. So it made it much a smaller payload and much easier to manage, of course. If you,
So you went back to text-based CSV.
exactly, it's basically a CSV, right? It's a JSON in a CSV. So if you go to the next page,
Oh. Yep. And I guess this is also the part about collections.
yes, and this was the interesting part. So we are looping through a lot of data. So now we have looping through a lot of data. We really didn't know why is it that when we went to production, the CPU went up almost exponentially, right? What is it that actually triggered that? We found some data hierarchies that actually were driven this, but it still is something that we couldn't really explain well. And while looking on how to optimize the code, we were using the collections. So this back to the question before. This is an example in the code of the collection that if you want to iterate through each, you have an array, and then you iterate through each, and then you perform activities underneath it. So it's a very elegant, I will say, or cool way to actually do a lot of logic in a very encapsulated way, right? Like JavaScript and Groovy actually is meant to. So a lot of us, I can notice that we use this because it's cool and it makes you feel good when something works, I will say. So we look a little bit on how efficient are those standard functions. And I found a very nice blog. I think we have a link on the next page, don't we, Daniel? Yes, and I found a very nice blog. Yes, where we had this table that shows a performance analysis on the different type of looping when you're doing Groovy. And as you can see, the higher the amount of records you have, collections collect each times become more and more expensive. Yes. So you can see that with the little records, there's not much difference. With 100 records, 1,000 records is, I think you can live with that. But at the moment that you have 10,000 records or 100,000 records, then you're gonna pay on CPU very, very expensive, right? So we changed a lot of the code, dropping collections and actually using traditional for loops, like in the old days of C++. So
Java, this was one of the things I had not seen coming.
This was definitely a surprise. Another thing is that on the right side, I have an example of an OData dollar batch request. Since I said that we're posting to this OData service in groups of 100 records, 200 records. So the payload that you're composing them is not an XML or a JSON, right? You are encapsulating those objects in MIME types. So the end result of the payload that you're going to send is a text file. This is what you are sending into a OData dollar batch request. Because of that, we needed to do a lot of string maneuvering, right? We have to add line returns and keep the spaces correct, and so all of this is done with the strings. And something that apparently a lot of people knew, I didn't knew, but when you're doing a lot of string concatenations, it quickly becomes expensive, especially in JavaScript and on a Groovy script. So even though it's so easy and neat to just do string concatenations like in the first example, the correct way to do this is doing string buffers. that really helps on the memory utilization on it. When I told Daniel, he just laughed at me. Oh, did you just find out about it?
Yeah, I think I created a web service or a website, I don't know, 20 years ago, something like that, in one of my first jobs. And it worked fine when we were doing it on just showing some sample test data. But then when they suddenly moved to production and showed all of the test data there, all the productive data, it just didn't work, and we had to scale up the CPU or get a bigger CPU. And then I found out this thing that each time you're doing these things, you discard some memory, and it needs to relink all of these different things, and then it just becomes expensive. So if you have arrays or loops that you're processing with these things and adding a lot of data into it, the first one is not really good. You need to use the string buffer, and then after the string buffer to string or whatever to get it out.
Correct. Yeah. So it definitely reflecting a little bit is that now that we have CPI, and there's definitely a lot of more coding done if you compare it to SAP PO, for example. So definitely, and that's not going to stop. I will say that I see that trend. I see the use cases around it, and I think that we all have to accept that we need to be better and more disciplined at coding, right? We really need to go back and read some of the classic engineering, software engineering 101s, right?
Yeah. And I guess this one I tried to add, and I guess this was back to the one where you had used the iteration process and split it out and say, okay, it's okay to use the CPI processing in some cases, but sometimes you want to take it out and just use plain old Groovy to handle some of these things. I have seen scenarios where customers have been using this splitter segregation in a wrong way, because they could have done I saw one example where they had taken a splitter, split the message, performed an XSLT, a message mapping, something else, and then grouped it together at the end, where it's like, okay, you could probably just have done it with one XSLT or message mapping, the full conversion. And I guess you need to consider, do we actually need all of this, or can we actually do it simpler with fewer steps?
Yeah, I think that now that you say that, something that reflected a lot is that now that we're living in this DevOps world, right, where everything is oriented towards cloud native, there's less time to actually reflect and to actually do traditional big blueprintings on how you're going to build stuff. So many times we start going for what is faster to make it work. Right. So I think part of our delivery approach should always be like, whenever you are delivering something, you need to maybe give it a little bit of space and then rethink and reevaluate, was that the right solution? Because now that we can actually deliver things faster and with the less overhead in between the deployment process and going live, it allows you to go faster, but you need to rethink that maybe some things there we needed to look back and revisit and tweak a little bit, right?
Yeah. And I guess this is just a testament that proves this optimization worked, that you had a process that took 3 hours and 49 minutes, and after the optimization just took 2 hours and 20 or 42 minutes. And some of the other ones is all half or something like that, or improved.
Exactly, but this was the first test, right? So what I wanted to show here is like, so how do I really prove this? Because of course I'm here and comparing the two flows before and after all the orchestration, but then you have to question, well, were the backend systems at the same load level, or there's things that you can it's like, it is faster, but we do not really know how much faster, or how is it really reacting on the CPU, and that's when we actually start leveraging on your tool, right? That's when they reach, hey, is there something that we can do here, right? So we were trying to find out what happened on this area. So this was the fun part. definitely, because at that point within the project, luckily we have already started using Daniel's tool for testing. There's we have not really done much of the monitoring part on it, but I knew there was something around it, so I asked Daniel, can I get access to it? And very quickly we were able to set up some monitoring of the CPU and memory in the tenants in all development tests, and that's where we really started seeing the real effect of our changes. All right. Here on the right side, here you can see the on the first upper chart is the CPU utilization in both the CPU, the front end, and the runtime. The one that says is map is
So
the
we have
runtime,
these
and
two, the map, that's the black one, the
yeah,
runtime, and the management is the UI.
yeah. And something that was on test already pleasant to see is that we were below 20% on the CPU when before we were very quickly aiming to 70, 80, 90%. So that was good to see. Also, we were able to make tests depending on how many transactions we group on. So we could see how reducing the groups between 200 transactions at a time or 100 transactions at a time can affect the memory utilization on the CPI tenant, right? So we started to really see some effect on our changes itself.
Yep.
If you go to the next slide, um, yeah, so this was the cool thing, right? So we were already going live and expecting that since in test was taking before 4 hours and now was taking 3. Hopefully, we will see around 4 hours now in production. We really were not sure how it would hit, but we went live. And since in production we have already received an extra node, and our optimization was all about CPU, the first thing that we saw and we were shocked is that it took less than 2 hours. We were expecting 4 hours, 5 hours, and it took less than 2 hours to process all the data. I even freaked out a little bit. I had to start checking if all the data was written and everything was there. But then that was really proof when we saw the CPU utilization and the chart on the right where you see the red, yellow, red. Those big spikes are before we deploy the new flow. And then immediately after we deploy the new flow, you can see how the CPU goes from 45% to like less than 5% on the production tenants, right? I
And
think that
then
is significant.
most of this processing time is then happening about posting data to the CAP system.
Exactly. So we things that we can reflect that where we need to put attention. If you have a lot of records and you are posting one at a time, the HTTP latency will hurt you, right? You can definitely spend a lot of time doing opening and closing connections. The other part is that definitely extracting and writing data to the systems is still the most heavier side, but we need to be very thoughtful about what kind of logic we're doing on CPI because it has limited resources. You have limited CPU capacity. So when you start doing a lot of data looping, it will hit CPI, and unless you have some monitoring or you're pulling data from the monitoring resources API, it will be very difficult to see to you what is really happening when you're deploying something, right?
And actually, when we developed this functionality, it was like, okay, this is pretty cool. We can track some graph. And then I was also considering the same concept that you're actually doing this in cloud, and SAP is supposed to be monitoring and supporting this. But I guess this proves that at least it makes sense to consider the CPU and being able to monitor what is going on here.
Not to mention SAP monitoring. So something that we talk a lot with the architects there. So they have a very, I would say, efficient resource preservance approach, especially for memory. So for example, here in the lower chart, you can see exactly when the garbage collector is called. Mm-hmm. So if you see the yellow line on the right side, for example, it's high, 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 and then at some point it just drops. When it drops in the memory utilization, that's when the garbage collector is dropped. So they are not calling the garbage collector periodically. They basically are saying I want this maximum amount of memory utilization, and the moment I reach to this level, garbage collector. So they are not always running it. They are just trying to secure the stability of the system without using too much resources internally. And on the CPU side, what they told us is that there's similar peak monitoring. So when it happens, if you're using a lot of CPU, uh, things will just start to get very, very slow. They will get to process. They will get to process. And when we were looking at this and troubleshooting it, we did see that even the first attempt that we were trying to load data, the one that took more than 6 hours, it did finish. The threads didn't close, and it did finish after 12 hours. But so the cloud architecture itself supports those kind of processes and supports in the way that saying like, I'm still in, my integrity is number one, so I will still finish my task. It will just take very long time, and that's very long time. That's when you pay it a very long time, right? So yeah, I think we learned a lot about the architecture during this exercise.
And yeah, if you have questions, just put them into the chat where you're watching this. Then we'll try to cover those. And I guess we are on the last one now.
Yeah. Yes. So definitely to take home is that keep an eye on those CPU utilization, right? I think CPU is the most important one in this case.
I guess so normally when you're creating, I can also see my CPU now with with all the video encoding is quite heavy consumed. But yeah, it would be nice in the CPI if you could actually see each iFlow and these metrics for it. The CPU,
yeah, that could correlate.
Yeah, so like a Unix top or whatever. Yeah.
Yes. So working with strings, definitely be careful with your stream buffer, with your string concatenations. Prefer that. Yeah, I have seen a lot of people using splitting and grouping. I think that you need to consider these things when you're going to split and group a lot of records. It's not the first time that I have had some trouble when we are going to be splitting and grouping big data sets. We have seen other customers also having odd behaviors, right, that we couldn't really explain before. But now that I know a little bit further into the CPU side, now I can really correlate. Oh, this definitely was happening because we were struggling with the resources that the tenant had, right?
Yeah.
So important, and SAP is very clear about it. When you're starting to use splitting and grouping in sub processes, it even shows you a warning, right? And it tells you like, beware that the behavior of the splitting artifact might be unpredictable when you're using this in a sub process, right? So
okay. Yeah, that makes sense. Okay, and then yeah.
And then test. Yeah, I think that's where when you come in, right? The possibility to be able to extract data sets from production and be able to run production-like tests on the other tenants.
Yeah, because I guess there it makes sense to understand what's the size of batches and being able to control them. But obviously, that can sometimes be a little challenging. And I guess we cannot really create test cases for a full 100 megabyte test case that simple. But I guess it's something we would need to consider how we can actually support those cases also, because it would make sense if you can just scale the number of line items that should be processed.
Yeah. Yes. Correct.
Cool. Thanks, and thanks for joining. If you have any questions along the way, and if you're even here, please do drop a note, just leave a comment. If you want to reach out to Juan, I guess you can. He has liked the post. Otherwise, you can always find his company and find him that way. Sapere.dk. Do you also have .com?
Good question.
Probably not.
I think it's only DK, right? I think .com will take you somewhere else. Yeah, wealth management. No, we cannot well manage your wealth. We can fix your integrations, but we cannot. Sapere decayed it.
Okay. Yep. Cool. But yeah, thanks for joining me. Thanks for sharing these insights on how or what you need to consider when doing integration. And let's see, no more questions. So thanks for joining. We will just end now.
Thank you very much.